In this video series, we're going to start taking a look at some of the more basic applications of trigonometric functions. We're going to start by solving for missing sides of angles in right triangles. And then we're going to use trigonometry to solve problems relating distance and angles. Then we're going to relate directional bearings and angles. And then finally, we're going to look at simple harmonic motion and how that can be modeled by using sine and cosine functions. So solving right triangles means that we're given a little bit of information about a right triangle. So we might be given like an angle and a side or a couple sides, and it's our job to find the remaining angles and sides. So let's say, for instance, that we have this right triangle. So we have an angle A is 37.6 degrees, and B is 26 centimeters, right? So this angle right here, A, and notice that the opposite of side A is going to be 37.6 degrees. And then also we're given that this side B is going to be equal to 26 centimeters. Right? Now, what we'd like to do is to be able to solve the remaining angles and sides. So let's start with angle B because I think that's going to be the easiest. Okay. Now, to find angle B, we know that the total angles or the total interior angles are 180. So that would mean that we take 180 degrees. We know that we have a right angle, which is 90 degrees. And then we also have that third angle or that second angle of 37.6 degrees, right? And we can go right into our calculator and figure out that that's going to be 52.4. All right, but let's just verify that. So we can clear all this out. So we're going to take 180 minus 90 minus the 37.6, and that's going to give us 52.4 degrees. Okay, so that's going to be equal to 52.4 degrees. All right, now try to make that look like a real 5. So we found all the angles. Okay, so that's pretty easy. So now let's try to figure out one of the sides. Okay, and let's try to find side A. Right now, we know that we can use trigonometry to do this because we know that the tangent function of an angle is equal to the opposite over the adjacent. Okay. Well, we have 37.6 degrees, so we can take the tangent of 37.6 degrees. That's going to be equal to the opposite, which is A in this case. And we're going to divide that by 26. Okay. Now to solve this, we could multiply both sides by 26. So 26 tangents of 37.6 degrees is going to be equal to A. And then we can approximate that. Notice it says that we need to approximate to 2 decimal places for the lengths. And so in our calculators, we're going to make sure we're in degree mode. Okay? And then we're going to take, we said 26 tangents of 37.6. So 26 tangents, 37.6. And that's going to give us 20.02 if we were to round it to 2 decimal places. Right? That's going to be 20.02 centimeters. And then finally, to figure out C, well, we could just use our Pythagorean theorem. So that's going to be C squared equals A squared, which we found to be 20.02 squared plus 26 squared. Okay. And so in our calculator, we're just going to clear this out. So we take 20.02, square it. And to that, we're going to add 26 squared. Right? And we'll go ahead and hit enter. So that's 1076.804. And then let's just take the square root of that number. Right? And that gives us 32.81. Okay, so that's going to be our C. The C square is going to be the 1076.80. And then we take the square root of both sides. And we said that that was going to be our 32.81 centimeters. All right, so that's how we can go ahead and solve the missing sides of a right triangle. Okay, now what if we're just given 2 sides? Okay, well, then what we can do is we can use an inverse function. All right, now let's find this missing side b first by using Pythagorean theorem. That should be the easiest thing. So we could take 52.8 squared equals 27.5 squared plus b squared. Right? And so we would take in our calculator 52.8 squared, right? And that gives us 2787.84. Okay, so that's 2787.84. Okay. And then we're going to take 27.5 and square it. So 27.5 to 27.5. Right. And we square that, and that gives us 756.25. So 756.25 plus b squared. Now we're going to subtract the 756.25 from both sides. So 756.25, we subtract that. We'll be left with b squared on the left side, and on the right side, excuse me. And then if we just take, and we have this number, we can just take this 52.8 squared minus, okay, that would be 2031.59. Okay, so 2031.59. And then finally, we just find the square root of that number. Okay, so we find the square root of this 2031.59. And that gives us 4507. Right, so take the square root, and that gives us 45.07 is equal to b. All right, so that's the easy part, okay? So even though we have a bunch of decimals in there, we certainly can do that fairly easily. Now, for us, let's find the remaining angles, okay? And realistically, we just need one angle, okay? So let's remember we have the relationship that tangent is the opposite over the adjacent. So we have 27.5 is B, and we have 45.07 for A. So that would mean that the tangent of theta is going to be equal to the opposite over the adjacent. So that would be 45.07 divided by 27.5. Right? And if we divided those out, okay, so in our calculator, we're going to take that 45.07 and we'll divide by 27.5. Right? That gives us 1.63, let's just say 1.64 since we're rounding everything to two decimal places. So that means that the tan of theta is going to be 1.64, all right? And then finally, to find our angle, we would take the inverse of the tangent, okay? So this would be inverse tangent of 1.64. Now make sure we're in degree mode in our calculator, which we are. We're going to go and we're going to find the inverse tangent of our 1.64. And that gives us 58.6 degrees. Okay, so that means that theta is approximately 58.6 degrees. Okay, which in this case is going to be this angle right here. Okay, because that's the angle that we took the opposite and adjacent of. So it's really A. So let me just rename that A, since that's the one that we were looking for. All right. And then finally, to find angle B, that's even easier because we know the measure of this angle. We know that this is a right angle. And so for angle B, that would be 180 minus 90 minus 58.6. Okay. If we shove that into our calculators, that should give us 31.4 degrees. But I'm just going to verify it by throwing it in a calculator really quickly. All right. So it was 180 minus 90 minus 58.6 degrees. All right, and that gives us 31.4, which we initially thought. Okay, so that's how we can solve our right triangles, okay, just by using some trigonometry. I always try to use the opposite over the adjacent just because once you have all the sides, it's pretty easy to use the tangent, okay, consistently. All right, so the next videos, we're going to take a look at how we can relate trigonometry to some more real life sorts of applications, keeping in mind that we're probably going to still have to solve some right triangle sorts of properties to be able to do that.